Hello everyone. So today we are going to see chemistry. So open your book. This is our book, so open. Okay. Let's see the content page first. So let's see how many topics are there in chemistry. Chapter 2. Chapter 2, Properties of Materials. Chapter 5, Reactivity. And Chapter 8, Rates of Reaction. Okay, there are 3 chapters in chemistry, and let's see the first chapter, Unit 2.1, Atomic Structure and the Periodic Table. Okay. Okay, this is our first page. 2.1, Atomic Structure and the Periodic Table. In this topic, you'll learn more about the structure of the atom and learn how the structure of the periodic table is related to the structure of the elements. Okay, so getting started. In 6th standard, 7th standard, we have studied about atoms, elements, protons, all those things. So there are some few questions for us, and let's do. List the parts of an atom. Give at least one fact about each part. Use the names of the parts and the information about them to write a description of the atom. Okay, let's see. List the parts of an atom. Okay, atom is divided into 3 parts. 3 parts, which is called as electrons, neutrons, and protons. Okay, there are three types of atoms called electrons, protons, neutrons. Okay, first question we have finished, and we shall give one fact about it. Okay, first I'll write about proton. So one fact about proton. A proton is a stable subatomic, okay? Stable subatomic particle. The symbol is P plus. Okay? Now we'll go for neutron. Okay, neutron. A fact about neutron. The neutron is a subatomic particle. Neutron means it has neutral charge. The symbol is R and O. Okay. Now, okay. Now we will. Now, what's remaining? Only electron. So, what do you know about electron? Okay, let's write about electron. Electron. So, what's electron? The electron is a subatomic particle with a negative charge. So, the symbol is E minus. Okay. Now, one fact also we have written. So, the second question we will do now. This is called structure of the atom or structure of an atom. Structure of an atom. So, this means a circle. This is the structure of the atom. Okay. And can you understand this? This is the second question answer. This is the nucleus which contains of neutrons and protons. Neutrons and protons. And this is called electrons. Okay. Before going, what's remaining in this page? Only the keywords. Come, let's discuss about keywords. I know some keywords you know, but we should discuss all of it. Come, let's do keywords. The first keyword is atomic number. Atomic number. What does it mean? Can you say? Atomic number. Okay. Number 1 is called atomic number. It's the number of protons in an atom. These keywords are very, very important. The number of protons in an atom. In an atom. Second one, electron shells. The layer of electrons arranged around the nucleus of an atom. Around the nucleus of an atom. So in this, what can you notice? In this definition. Okay. Okay, let's say atomic number. If you need to remember atomic number, what should come in your mind? Number of protons. And electron shells means what should come? Layers. Don't remember that. Electron shells, which is called as layers also. Okay? Then next one, the third keyword is electronic structures. Correct. So that means the arrangement of electrons, the arrangement of electrons in the shells or levels around the nucleus of an atom. Around the nucleus of an atom. Around the nucleus of an atom. So what's the fourth keyword? The fourth keyword is electrostatic forces. The fourth keyword is electrostatic forces. Okay, fourth one, electrostatic forces. Forces of attraction. Forces of attraction. Forces of attraction between particles with opposite electrical charges. Electrical charges. What's the fifth keyword? Energy levels. That's so important, but it almost combines with electron shells. So let's see that later. Fifth one, mass number. Very important. Mass number and atomic number is very, very important. Mass number. The number of protons, and neutrons in an atom added together. Okay, the last one is periodic table. You know, everyone knows what's periodic table, correct? But we need a proper definition of the sixth keyword, periodic table. What's the keyword? Sixth one, periodic table. It's a table of all elements placed in the order of their atomic number. Okay, we finished this page, and I think you will know these keywords very well. So come, let's go to turn page 49. Everyone turn pages. I turn. Okay, the periodic table. So in stage 8, you learned about the first 20 elements and the symbols in the periodic table. Now, you will learn more about the structure of the atoms of these elements. Okay, so here these yellow are metals, these blue are non-metals. Okay, okay. So, come let's move. The atoms of the elements increase in mass as they progress from left to right, starting with hydrogen and downwards in the periodic table. For example, an atom of hydrogen has less mass than atom of sodium. Okay, search hydrogen. Hydrogen and atom of sodium. Sodium is here 11, and here is 1, 23, and same 1. So, for example, an atom of hydrogen has less than an atom of sodium, correct? Each element has an atomic number. This tells you how many protons it contains. How many protons it contains. The atomic number increases by 1 with every element. Each element has a mass number. This tells you how many protons and neutrons each atom in the element has in total. Protons have a positive charge. Electrons have a negative charge. Neutrons have no charge. So this describes P plus, E minus, and NO, which is called neutron. An atom has no overall charge. This is very important. So this is very important sentence. Come on. An atom has no overall charge because the number of protons is the same as the number of electrons. This I'll explain in detail. Okay. Now, for example, the heading is an atom has no overall charge. This is the heading. Overall charge. So, first one, lithium I will take. Lithium two 7. Atomic number, mass number. Okay, lithium 2 7. Atomic number, mass number. Now, in this, 2 is the atomic number. 3. Atomic number is equal to 3. Mass number is equal to 7. Number of protons is equal to 3. Number of neutrons is equal to 4. That's how. 7 minus 3, which is mass number minus atomic number, is 7 minus 3, which is equal to 4. Number of electrons is equal to 3. Why? Why? Can you guess? We have, what's the heading? An atom has no overall charge. Okay. Because you should explain like this. The electrons in the lithium has 3 electrons because protons have a positive charge electrons have negative charge neutrons have no charge. Neutrons have no charge. So, an atom has no overall charge. So, it is equal. The protons and the electrons are equal. However, it's equal. Okay. Now, we'll go to the next page. Page number 50. This one. The higher the mass number, the more the atom has. Hydrogen has an atomic mass of 1. Carbon has an atomic mass of 12. So, one atom of carbon has 12 times more than one atom of hydrogen. Okay, this is an example. Let's compare the mass of piece of sodium. Measuring 1 centimeter. 1 centimeter with the mass of piece of iron. This is sodium. So the mass of the piece sodium is 0.97 grams. And the piece of iron is 7.87 grams. The mass of the iron is more than the mass of the sodium. Okay, this is density definition. This measure of the mass for a fixed volume of a substance is called the density. The density is given using the unit G centimeter cube. The density of iron is 7.87 G centimeter cube and that of the sodium 0.97 G centimeter cube. So iron is more dense than sodium. This G centimeter cube is the unit of density. So for further information, we'll go to the topic 3.1. Let's see in the next video for that. And arranging electrons. Arranging electrons. So, in stage 8, you learned about the development of a model for the structure of the atom. This used ideas from a number of scientists used as J.J. Thomson, Ernest Rutherford. They developed the model shown here. So this is Rutherford's model. Rutherford's model. In 1930, the Danish scientist Niels Bohr developed Rutherford's model of the atom further. He had the idea and the evidence that the electrons move in different electron shells, also called energy shells, around the nucleus. He was awarded the Nobel Prize for this work. His idea changed the model of the structure of the atom to the one we use today. So, this is Rutherford's model. And this is whose model? Danish scientists, and this is the current model. They developed current model. Okay? Okay, turn your page. 2.1 atomic structure in the periodic table. So the electrons are arranged in electron shells around the nucleus. Yeah, right? This is electronic structure. The first electron shell only has room for 2 electrons. Remember this point. One room for 2 guests, and 2 rooms for 8 guests, and 3 rooms for 8 guests also, up to 8 guests. So, this one, beryllium's. Okay, read this first. The arrangement of the electrons in an atom is often written as numbers. For example, the electronic arrangement for a boron atom can be written as 2, 3. Do you know how? 2, 3. This is the boron. Okay. Here, there is the nucleus. And this is one shell, room for 2 guests. So, boron's atomic number is 5. Okay? 1, 2. Which is 2 and remaining 3 is there. So, in the second shell, you can fill up to 8. So, I'll put 3. There are 3 shells and this is 5. This is the diagram. Or you can put like this also. You can't use a third shell because the second shell is not filled. That's why. Okay, let's solve some questions. The questions: how many electrons are there in an atom of carbon? You can see the periodic table, which is 6. First question, 6. How many protons are there in an atom of beryllium? Atomic number and mass number, protons and electrons are the same. I explained you why, right? So, it's 4. And third question, how many neutrons are there in an atom of boron? So, in an atom of boron, let's check the periodic table. I have checked the periodic table, which is third question, how many neutrons are there in an atom of boron, which is 11 minus 5, which is equal to 6. Fourth question, how many neutrons are there in an atom of boron? Neutrons are there in atom of boron. That's what we finished. Draw a diagram to show Show the structure of an atom of magnesium. I will. The atomic number of magnesium is 12. So 2 and another 1 second. Here 2 only I can fill, and next magnesium I should fill 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have finished 10. We should fill 12, 1, 2. Or else you can put like this also or like this. So I have filled 12. This is the diagram. And next, fifth question. What is the name of the element that has the electronic structure 283? So you should do it as 2 plus 8 plus 3, which is equal to 13, which is aluminium. And 6, the same. It's a diagram, right? So the nucleus, then fluorine 2, and 2, here 2, here also 2, and here 1, which is fluorine 2, 7. Fluorine 2, 7. This is nucleus. This is the electronic shell. And last, the seventh question. How was the model of the atom we use today different from the Rutherford model? This is our model. This is our model. And Rutherford model was very different. I showed you. This is this was Rutherford's model. This is current model I showed you. So the answer for this is the model of the atom. The model of the atom we use today is different from the Rutherford's model. Rutherford's model is that the electrons move in different electron Shells around the nucleus, unlike in Rutherford's model. Rutherford's model. That's all his answer. And in this question, this is the main. How is the model? Should give reason and different. Okay? And thank you. Bye.